Hello everyone, today I am going to discuss about remainder theorem. This is very important topic under number system. Last year in 2024, in each slot there is one question from this chapter. So let's start remainder theorem. So give heading, and I assume you all making notes with me, okay? So remainder theorem. Under remainder theorem, the first important theorem, that is Euler's. Last year, all the three questions, in each slot there is one question, all the three questions are based on this concept, Euler's theorem. Euler's theorem to find the remainder. So what is this? So give heading Euler's theorem to find the remainder. Achha, I'll give you one example so that you can understand how the question is formed and what is the thought process, the approach. Suppose 11 to the power 62. This is the dividend. 11 is multiplied 62 number of times. When it is divided by 7, find the remainder. 11 to the power 62, when it is divided by 7, this is the dividend, this is the divisor. Dividend, it's a huge number, okay? When this one is divided by 7, how to find the remainder? Now, the approach. Achha, where you can apply Euler's and the structure. Whenever question is in this way, a to the power m, when it is divided by b, find the remainder. Means dividend is a to the power m and your divisor is b. This is the structure, okay? But you cannot apply Euler's theorem directly, it has certain restriction. So first we will discuss about the restriction. If these two numbers are co-prime with each other, co-prime means HCF of a and b, it must be 1. If they are co-prime, then you can apply Euler's theorem. So it has the restriction. Now it has only two steps. Step number 1, when a is divided by b, find the remainder. Step 2, power is m here, m when it is divided by Euler's number of b, find the remainder. So two steps are there. A, when it is divided by b, find the remainder. Step number 2, power is m here, m when it is divided by Euler's number of b. And how to find Euler's number? Euler's number of b, that is equal to b whole into 1 minus 1 by p whole into 1 minus 1 by q and so on. Where p and q, these are distinct prime factors. Distinct prime factors of b. Okay. So in this way we apply. Suppose for example, how to find this Euler's number? Let's say Euler's number of 210. So first of all, you do prime factorization for 210. If I do prime factorization, if I divided by 2 here, this is 105, divided by 5 here, this is 21, divided by 7 here, I will get 3. So 4 distinct factors are there. So how to find Euler's number? Now first of all, you write b whole into 1 minus 1 by 2. Here 2, 3, 5, 7 are the factors of 210. 1 minus 1 by 3 whole into 1 minus 1 by 5 whole into 1 minus 1 by 7. If I apply, this is 210 into LCM is 2 here, this is 2 minus 1, LCM 3, 3 minus 1, 2, so this is 4 by 5 and this is 6 by 7. 2, 3, 5, 7 are the factors of 210, they get cancelled. So if I multiply 8 into 6, 48. So Euler's number of 210 is 48. At the last, it is visible, 48, 4, 8. Okay, fine. Now, Euler's number of 7, any prime number. Achha, here I will write Euler's number of any prime number. Euler's number of 7 is, first you write 7 whole into 1 minus 1 by 7. Because 7 has only one prime factor. Prime factor, 1 is neither prime nor composite. So for 7, it has two factors. It's a prime number. I will consider 7. So 7 whole into 1 minus 1 by 7. So LCM here is 7, 6 by 7, 7, 7 get cancelled, I will get 6. So for a prime number, Euler's number is number minus 1. Euler's number of 11 is 10, 13 is 12, Euler's number of 17, it is 16. Okay, in this way you have to find. Now look here. Now I will relate here. First of all, when I apply Euler's, I have to check. It has certain restriction. Ki 11 and 7, either they are co-prime or not. Co-prime means SCF is 1. And you know between two prime number, SCF is 1. So they are co-prime. So here I can apply Euler's. So step number 1, 11 when it is divided by 7, find the remainder. Here it is written A when it is divided by B, find the remainder. 11 when it is divided by 7, find the remainder. Then power is 62 when it is divided by Euler's number of 7, find the remainder. 11 by 7, remainder is 4. 11 when it is divided by 7, 7 into 1, 7, remainder is 4. And 62, and you know Euler's number of 7 is what? 6. So 62 by 6, remainder is 2. So this is 4 square, that is equal to 16. But this is not my answer. Why? Because 16 is greater than the divisor. And here divisor is 7. So when answer is greater than the divisor, you know remainder is always less than the divisor. But here I will get 16 which is greater than 7. So again I have to divide. So my final answer is 16 by 7, I will get 2. My answer is 2. Clear? Here my answer is 2. Thought process clear? How to apply? Once again, a to the power n when it is divided by b. This is the structure, syntax of what? Euler's theorem. Here a to the power m, it is the dividend, b is the divisor. How to find the remainder? Before you apply Euler's theorem, first of all you have to check whether these two numbers they are co-prime or not. Co-prime means SCF of a and b must be 1. If it is satisfied, then you apply Euler's theorem. And Euler's theorem has two steps. Step number 1, a when it is divided by b, find the remainder. Power is m, m when it is divided by Euler's number of b, find the remainder. So two steps are there. Done. If you understand, I will give you one question, and this is a PYQ already asked last year. Okay. Take this screenshot here or write it down. Okay. Take this screenshot first. Okay. Okay. So here the question number 1, 10 to the power 100 when it is divided by 7, find the remainder. And this was asked in CAT 2024 slot 1. 10 to the power 100, dividend is 10 to the power 100, it's a huge number. 10 is multiplied 100 number of times. 10 to the power 100 when it is divided by 7, find the remainder. So what are the steps? Step number 1, 10 when it is divided by 7, find the remainder. Because these two are co-prime, so you can apply Euler's theorem. One prime, one composite, SCF is 1. Done. So co-prime, so you can apply Euler's theorem. Now step number 1, 10 when it is divided by 7, find the remainder. Step number 2, 100 when it is divided by Euler's number of 7, find the remainder. So two steps are there. 10 by 7, remainder is 3. And 100, Euler's number of 7 is what? 6, already discussed last question. So 100 by 6, you know 96 is divisible by 6. So 100 by 6, if I divide, remainder is 4. And 3 to the power 4 is 81. Again, answer 81, it is greater than what? Divisor, 7. So this is not my answer. Once again I have to divide, so answer for this question is 81 when it is divided by 7. You know 77 is divisible by 7, so remainder is 4. Answer for this question is 4. Understood? Very easy question, one line question. If you understand Euler's theorem, if you understand this structure, syntax, easily you can answer. Okay. Question number 2. Three to the power 333 when it is divided by 11, find the remainder. Again, this was asked in CAT 2024 slot 2. All are PYQ. Okay. So you can handle. You can directly apply this theorem. Okay, direct one. In slot 3, that is a good question. I will solve next. Now here again, first of all check 3 and 11. Co-prime? Yes. If it is co-prime, then apply Euler's theorem. 3 when it is divided by 11, find the remainder. Step number 1. And here power is 333. When it is divided by Euler's number of 11, find the remainder. So 2 steps are there. 3 by 11, 3 divided by 11. 11 into 0, 0. Remainder is what? 3. So here when a smaller number divided by bigger number, remainder is always smaller number. So this is 3. And Euler's number of 11. 11 is a prime number. So number minus 1. So Euler's number of 11 is 10. If I divide, this is 3 cube. 3 cube is 27. Again 27 is greater than 11. Divisor is 11. Answer is 27. Not possible. So what you have to do? Again you have to divide. So answer for this question is 27 by 11. 11 into 2, 22. The remainder is 5. This was asked in last year. Very easy. If you understand this structure, easily you can answer. 2 steps are there. Once again, 3. When it is divided by 11, find the remainder. Step number 2, 333. When it is divided by Euler's number of the divisor, means 11, find the remainder. So 2 steps are there. And 2 times you have to find the remainder, that's it. Are you clear? Understood now? Note it down, one by one we will solve the PYQ so that you can understand the structure. Okay? How to handle Euler's theorem. Okay? Okay, example number 3. मैं यहाँ पे ये मान के चल रहा हूँ आप सब मेरे साथ नोट बना रहे हो ठीक है वन बाय वन यू सॉल्व दिस थिंग विल बी इजी आफ्टर 10 या 15 मिनट यू कैन हैंडल ईच एंड एवरी क्वेश्चन फ्रॉम दिस चैप्टर रिमाइंडर थ्योरम पर्टिकुलरली फ्रॉम यूलर्स फॉर्मेट लिटिल थ्योरम विल्सन्स थ्योरम you can handle. Okay, and you can expect one question from here. Okay, ten to the power 68 when it is divided by 13, find the remainder. And this was asked in CAT 2024 slot 3. Okay, find the remainder. Question is like this: find the remainder when 10 to the power 68 is divided by 13. So again, first of all you have to check whether these two numbers are co-prime or not. Yes, co-prime. So you can apply. Why co-prime? This is a prime number, composite number. One prime, one composite. So SCF is 1. Now if it is satisfied, how to apply Euler's theorem? Now it has 2 steps. Again and again I will say same thing. 10 when it is divided by 13, find the remainder. And step number 2, 68 when it is divided by Euler's number of 13, find the remainder. So 2 steps are there. 10 by 13, when a smaller number divided by bigger number, remainder is always the smaller number, 10. And here 68, Euler's number of 13 is 12. So 68 by 12, remainder is 8. Because 60 is divisible by 12. So answer is what? 10 to the power 8. But 10 to the power 8 is the bigger number. Here divisor is 13. This one is greater than 13. Process you know. Again I have to divide. Here answer how to find? Now 10 to the power 8. Again when it is divided by 13, find the remainder. But important is, again if I apply Euler's, 10 by 13 remainder is 10. 8 by Euler's number of 13, that means 12. Again remainder is 8. Again if I apply Euler's, I will get same answer. So here thought process matters. How to handle? Look here carefully. Think about, look, this is the thought process. Think about power of 10 which is close to 13 or multiples of 13. Once again, think about powers of 10 which is close to 13 or multiples of 13. This is the thought process. You can say, here write down this thought process. Which power of 10 is close to 13 or multiples of 13. Just think. Just you think this one. Now, you know 1001. It's a prime number? No. It is not a prime number. It is divisible by 13. It is 13k form. This one is 13k form. 1001. If I divide by 13, 13 into 7, 91. Remainder is 9. Again 9, 1. 13 into 7, 91. So here I can write 10 cube. 10 cube. It is close to multiples of 13. Achha, if I write 10 cube, power is 2. 3 into 2, 6. Into 10 square. Separately here I will write. When it is divided by 13, how to find the remainder? Now, this is what? This is 1000. Multiples of 13, you can say 1001. Achha, if I divide, how much I will get? If I will divide, how much I will get? I will get -1. So, why -1? Remainder is negative. Here I apply negative remainder concept. So, what is this negative remainder concept? Look here, this one is very, very important. Negative remainder concept. Suppose I will say 65. When it is divided by 9, how to find the remainder? You know, every division, according to this concept, every division has 2 remainder. 65, when it is divided by 9, it has 2 remainder. One is positive, another one is negative, according to this concept. Okay. And why we use negative remainder concept? Why negative remainder? To minimize the complexity of the calculation. That's why we use negative remainder. Otherwise, from childhood, whatever we are solving, we are dividing, remainder is what? Remainder is always positive. Then, the final answer is always positive, but negative remainder we use to minimize the complexity of the calculation. Now here, according to this statement, this concept, think about a number which is just less than 65, but divisible by 9, that is 63. Similarly, think about a number which is just greater than 65, but divisible by 9, that is 72. You have 63, but your desired number is 65. So what you have to add here so that you will get 65? Now plus 2. So plus 2 is one of the remainder. Similarly, you have 72, but you want 65. Desired number is 65. What modification you do here? Now minus 7. So every division has 2 remainder. Here plus minus, plus 2 minus 7. Done. Second key point, magnitude of sum of both. Magnitude of sum of both the remainder. That is equal to divisor. So magnitude wise, plus 2 the magnitude 2, minus 7 magnitude 7, 2 plus 7 equal to 9. That become what? That is equal to divisor. Clear? So same thing here I apply. 1000. When it is divided by 1001, 13 the multiple. 1000 by 1001. The remainder is what? Minus 1. If I consider 1000, then it's a square, it will take more time. So better you use negative remainder. So minus 1 here, I will get, if I solve this one, 10 cube, when it is divided by 13, remainder is minus 1. Now minus 1 square, 1. Operator here is multiplication. This is 100 by 13. 100 by 13, remainder is 9. Because 91 is divisible by 13. Now 1 into 13, 1 into 9. Why it is 1? Because minus 1 and here power is 2. So minus 1 square, 1. So 1 into 9, answer is 9. So answer for this question is 9. Answer for this question is 9. Here I will write. Here I will get minus 1. Minus 1 square. Operator here is multiplication. And 100 by 13. This is 9. So answer for this question is 9. And this one is important. This thought process matters. After getting 10 to the power 8. After getting 10 to the power 8. This is the thought process. You have to think which power of 10 it is close to 13 or multiples of 13. And you know 1001, it's not a prime number. 1001, it is not a prime number. It's a composite number. It is 13k form. Similarly, if I will say 1003, 1003, it is 17k form. Similarly, 1007, 1007, it is 19k form. sorry 17k, this one is 13k, this one is 13k form. Now if I divide this number by 17, okay, so how much I will get? Again it is divisible, so this is 17k form and this is 19k form. Then you cross check, 19 into 5 here, 19 into 5 95, remainder is 5 57, 19 into 3 57, so it is divisible by 19. So the smallest prime number, 4-digit prime number is 1009. This one is a prime number, smallest prime number, smallest 4-digit prime number, that is 1009. Done. Okay, just write it down or take this screenshot here. Next question, you just write it down. Nine to the power 82. When it is divided by 45, find the remainder. Here the question is, here I will write down the question. The structure is like this. Find the remainder when 9 to the power 82 is divided by 45. Find the remainder when 9 to the power 82 is divided by 45. So again, when I apply Euler's theorem, I have to check whether these two numbers are co-prime or not. But here 9 and 45 also multiples of 9. So here SCF is 9, so it is not co-prime. That means you cannot apply Euler's theorem directly. So I have to do certain modification. So same thing I can write in this way. This is 9 to the power 82 when it is divided by 45. This can be written as 9 to the power 82 can be written as 9 to the power 81 into 9. When it is divided by 45 means 9 into 5. So these two get cancelled. So here cancellation factor is what? You can remember cancellation factor by which number you simplify, and 9. Now the question is what? 9 to the power 81 when it is divided by 5. I am going to find the remainder. Here I am going to find the remainder. Now you check. Can you apply Euler's theorem? Yes. 9 and 5 co-prime. So now if I apply Euler's theorem, 9 when it is divided by 5. 9 when it is divided by 5, find the remainder. And 81 when it is divided by Euler's number of 5, find the remainder. So 9 by 5, remainder is 4. And 81 when it is divided by Euler's number of 5 is what? 4. So 81 by 4, remainder is 1. 80 is divisible by 4. So answer is 4. But this is not my final answer. Here answer is 4 when divisor is 5, but the actual divisor is 45. So here cancellation factor is 9. So at the end you have to multiply 9. 9 into 4, 36. Answer is 36. Write it down. This is another type. If they are co-prime, no issue, directly you apply Euler's theorem. But if these two numbers are not co-prime, you do modification first. After that you simplify. So this is another type. Previous question, after solving I will get 10 to the power 8. Remainder is 10 to the power 8, but the divisor there is 13, which is not possible. So this is one type and this is another type. 10 to the power 8, huge number. So there I do modification. We apply the thought process ki which power of 10 it is close to 13 or multiples of 13. But here these two, they are not co-prime, so I cannot apply Euler's theorem directly. So I do modification first. And how I do modification? Here cancellation factor is 9. So at the end, after taking this 5, when I divide, I will get my answer is 4. At the end, I have to multiply with cancellation factor. So final answer is 36. Just note it down. Okay. Under Euler's, another type, splitting the denominator. You can say application of Euler's theorem. Application of Euler's theorem. Splitting the denominator concept. Splitting the denominator. Here the question is, find the remainder when 2 to the power 90 is divided by 91. Two to the power 90. 2 to the power 90 when it is divided by 91, find the remainder. So first of all, you all try apply the Euler's theorem. Take the difficulties. Okay, if you apply the Euler's theorem, you can face more difficulty. This will be lengthy. Okay, here I will apply the Euler's theorem first. First check 2 when it is divided by 91, find the remainder. These two are co-prime, so directly I can apply 90 when it is divided by Euler's number of 91. 2 by 91, smaller number divided by bigger number, remainder is smaller number. 90 divided by Euler's number of 91. 91 can be written as 13 into 7. So Euler's number of 91, this is equal to 91 whole into 1 minus 1 by 7 whole into 1 minus 1 by 13. So here it is 91 into LCM here is 7, 7 minus 1 6, and here LCM is 13, 13 minus 1 12. This get cancelled. 12 into 6 is how much? 72. Euler's number 72. So here this is 2, 90 by 72. 90 when it is divided by 72. 72 into 1, 72. So remainder is 18. 2 to the power 18. Huge number. It is a bigger number. Now it is lengthy. Now I have to divide this number again. My answer here is 2 to the power 18 when it is divided by 91, find the remainder. And here I have to think which power of 2 it is close to 91 or multiples of 91. It will take more time. So instead, what I will do, I will split the denominator. So here the next concept is splitting the denominator concept. Splitting the denominator. Splitting the denominator concept under Euler's theorem. So what do you mean by this? Here denominator is 91. 91 can be written as 13 into 7. So what I will do, here dividend is 2 to the power 90. Dividend 2 to the power 90. So 2 to the power 90 when it is divided by 13, find the remainder. This is step number 1. Step number 2, 2 to the power 90 when it is divided by 7. 2 to the power 90 when it is divided by 7, find the remainder. So 2 steps you have to perform. Step number 1, step number 2. Dividend same, number same. Same number when it is divided by 7, find the remainder. Same number when it is divided by 13, find the remainder. This is splitting the denominator concept. 2 to the power 90 when it is divided by 13, find the remainder. 2 to the power 90 when it is divided by 7, find the remainder. When I apply Euler's theorem here, co-prime, so I can apply. So 2 by 13, directly I will write 2. Remainder is 2. 90 when it is divided by 12. Euler's number of 12. 12 means 84 is divisible. 84. So here it is 6. So 64 is greater than 13. So here answer is 64 when it is divided by 13. I will get 13 into 4, 52. Remainder is 12. Similarly, remainder is 12. Can you write the number here? Can you find the number? Number means what? This number is nothing but 2 to the power 90. I can write the number in this way. Here divisor is 13. So this is 13. Let's say quotient, I don't know the quotient. 13 into y, and here remainder is 12. Okay, so here number can be written in this form. You know dividend, this is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. I apply that concept. Similarly, step number 2, 2 when it is divided by 7, remainder is 2. 90 when it is divided by 6 is 0. 2 to the power 0 means 1. So here same number can be written as, this is 7x plus remainder is 1. Here it is visible na, 7x plus 1. Okay. It is not visible here. I will write here. You check here. Next step, here I will write 2 to the power 90 when it is divided by 7. This is 2 by 7, find the remainder. 90 divided by Euler's number of 7, find the remainder. 2 by 7, remainder is 2. 90 by 6, it is divisible, remainder is 0, so answer is 1. So here number can be written as, this is equal to, divisor is 7, so this is 7x. Here divisor is 13, that's why here I write 13y. Here x is the quotient I don't know, let's say x, plus remainder is 1. This is my equation number 2. And if you compare, both the numbers are same, this is 2 to the power 90. So I can equate these two numbers. And if I observe these two sides, right hand side, this is 7x plus 1, here it is written 13y plus 12. So I can write what? 7x plus 1, this is equal to 13y plus 12. So here 7x is equal to how much? 7x. Take this 1 to right hand side. So this is 7x is equal to 13y plus 11. 7x is equal to 7x 13y plus 11. 13y plus 11. Now how to handle? By heat and trial method. Heat and trial method means what? Now I keep on putting the value of y. If y equal to 0, because x and y both are what? Both x and y, they are quotient. Okay, means integer value. So if I put y equal to 0, so this is 7x is equal to 11. 7x 11. So x is not here, x, it is not the integral value, a decimal. Okay, then I keep on putting the value. Then I put y equal to 1. If I put y equal to 1, then 7x is equal to how much? This is 13 plus 11, 24. Again 24 is not divisible by 7. If I put y equal to 2, by heat and trial method we have to solve. We keep on putting the value of a y, okay, unless and until x is an integer. So here 7x is 26 plus 11, 37. Again it is not divisible by 7. 37 is not divisible by 7. If I put y equal to 3, 7x is equal to, here if I put 3, 39 plus 11, 50, not divisible. 50 is not divisible by 7. Then I put y equal to 4. If I put y equal to 4, 7x is equal to 52 plus 11, 63. It is divisible. So here x is equal to how much? 9. X is equal to 9. Now if I put the value of x here, or you can put the value of y here, you will get same answer. If I put 9 here, how much I will get? The number is the smallest number. You can say smallest number. Smallest number. This is equal to 3 plus 1, 64. So smallest number is 64. Actually this is my answer. Why this is my answer? Now general form of the number. General form of the number. This is 64 and is the smallest number plus LCM of both the divisor. Here divisors are what? 7 and 13. 7 and 91. 91. Okay. LCM is 91k. So when I divide this number 64 plus 91k, when it is divided by 91, 64 by 91, remainder is 64. 91k by 91, remainder 0, operator here is plus, so answer is 64. So after putting the value of x or y, whatever you can put, if I put the value of x here, I will get same value. If I put y value here, 13 into 4, 52 plus 12, 64. Done. So this is the smallest number and this will decide my answer. This is nothing but my answer. The smallest number is nothing but the remainder. Why? General form of the number is this one. When I divide this number, means 2 to the power 90, it can be written in this form. When it is divided by 91, I will get remainder is 64. Write it down. And this is the important one. Okay, then give heading Fermat little theorem. Okay, what do you mean by Fermat's little theorem? Fermat's little theorem. So under remainder theorem, the second one, this is Fermat little theorem, equally important. So first of all, we discuss about the structure. A to the power p minus 1, where p stands for prime number. When it is divided by p, a remainder is 1. But here condition is a and p must be co-prime with each other, just like Euler's. A and p must be co-prime, means SCF of a comma p, this is equal to 1. SCF of a comma p must be co-prime with each other. Then I can apply Fermat little theorem. And answer for this one is remainder is 1. Example, you can say 85 when it is divided, 85 to the power 145 when it is divided by 73, find the remainder. 85 to the power 145 when it is divided by 73, find the remainder. So here, first of all, you have to check whether 73 is prime or not. Yes, it is a prime number. But if it is 73, power must be what? 72. Then I can apply. Here p stands for prime number. But if p minus 1 is present at the power, here dividend is a to the power p minus 1. But here base is a and power is p minus 1. Whatever divisor is there, divisor minus 1. But here 145 is present. So I have to do modification. Directly I cannot apply. So here I can write this is 85. If I write 72 here, 72 into 2 is what? 144. Then I need another 85. Power is 1, and if a base same, you can add the power. Now I will get what? 145. When it is divided by 73, here I am going to find the remainder. Now here I can apply Fermat little theorem. 85 to the power 72. First of all, check 85 and 73 co-prime. One prime number, one composite number. SCF is 1. Now here power is 72. Here prime number is 73 and here power is 72. So here if I apply Fermat little theorem, answer is 1. So this is 1 and here power is 2. So 1 square. Operator is multiplication. Now 85 by 73, remainder is 12. So 1 into 12, answer is 12. Okay, answer for this question is 12. Answer for this question is 12. Write it down. Answer here is 12. Example number 2. Just write it down. I will erase this one. Then I will write down the next one. Structure understood? Okay. Question number 2. 4 to the power 160. This is the dividend. When it is divided by 187, find the remainder. Here 4 and 187 co-prime, but 187 is not a prime number. You cannot apply Fermat little theorem directly. Once again, syntax is what? A to the power p minus 1. When it is divided by p, remainder is 1. Here p stands for prime number. P stands for prime number. Condition is a and p must be co-prime with each other. Co-prime means SCF must be 1. SCF of a and p, it must be 1. So here condition satisfied. 4 and 187 co-prime, but 187 is not a prime number. This is what? 11 into 17. 17 into 10, 170. Another 17, 187. So here how to handle? I will split the denominator. 187 can be written as 11 into 17. So here what I will do, 4 to the power 160 when it is divided by 11, I am going to find the remainder. Step number 1, splitting the denominator concept. This is 4 to the power 160, same number when it is divided by 17, find the remainder. So 2 steps I have to perform here. Now this is 4, here this is 11, so here if I will write 10, I can apply the Fermat-Little theorem. And here power is 16. You can apply Euler's also. Now after learning all this, according to your convenience you apply. But better if you apply Fermat-Little theorem. If here the divisor is prime, more important, okay. Divisor is prime, you can apply, otherwise no. So here I will get 1. If I solve this one, 1 to the power 16, answer is 1. Similarly here, this is 4. 17 is a prime number. If I write 16 here, 16 into 10, 160. When it is divided by 17, remainder is what? Again here, this is 1 to the power 10, again 1. And in both the case, this is 1 and 1. The final answer is what? General form. General form or the logic here is 4 to the power 160 when it is divided by LCM of the divisor. LCM of the divisor. Divisor is 11 and 17. I will get the same remainder. Same remainder means 1. And LCM here is just multiply. Because between two prime number, LCM is their multiplication. So 17 into 11, how much? 187. So answer here is 1. Answer for this question is 1. Easy. So you can say this is the application of Fermat-Little theorem. Application of Fermat-Little theorem. Done? Noted? Under this, the next important theorem is Wilson's theorem. Under remainder theorem, the next one is Wilson's theorem. Wilson theorem to find the remainder. Wilson's theorem to find the remainder. So give heading. Wilson's theorem to find the remainder. And here the syntax is more important. Structure is more important. Structure of the question is when p minus 1 factorial, when it is divided by p, find the remainder. And here p stands for prime number. So p minus 1 factorial when it is divided by p. When it is divided by p, remainder is what? P minus 1 or minus 1. You know every division has two remainder. One is positive and the one is negative. Magnitude of sum of both is equal to divisor. Magnitude wise, minus 1 of magnitude is what? 1. Minus 1 plus 1 get cancelled, so I will get p. So I can write these two. I can write this two, but you can follow any one. But the final answer must be positive. Example, if I will say 16 factorial when it is divided by 17, remainder is how much? 16 factorial when it is divided by 17. 17 is a prime number. 17 minus 1 is 16 factorial is there. So here directly you apply 17 minus 1, this is equal to how much? 16. 17 minus 1 is my answer, or minus 1 or minus 1, but final answer must be positive. Now the quiz is, next question you can say, I will give you another, under this Wilson's theorem you have three formulas. I will derive one by one and I will prove also. So your quiz number 2, 15 factorial when it is divided by 17, find the remainder. Achha, how to handle? You know this one, 16 factorial when it is divided by 17, remainder is 16. Achha, this 16 factorial, it can be written as what? Now 16 into 15 factorial. 16 factorial can be written as 16 into 15 factorial. When it is divided by 17, answer you already know, your answer is what? 16. Your answer is 16. Okay. Now I need this one, 15 factorial by 17. Here 15 factorial when it is divided by 17, remainder I want. So I take this 16 to right hand side. Or you can say this is 16 or minus 1. 16 by 17. 16 when it is divided by 17, remainder is minus 1. And if I take this minus 1 to right hand side, 16 by minus 1 minus 16, minus 1 by minus 1, that is 1. So final answer is what? If I will say 15 factorial when it is divided by 17, remainder here is 1. Remainder here is 1. Why 1? I take this minus 1 to right hand side, 16 by minus 1 negative, minus 16. Minus 1 by minus 1, this is 1. So final answer is what? Final answer is 1. So under this Wilson's theorem, the second important formula you can remember in this way. This is the first one. This is the first one. The second one is p minus 2 factorial. When it is divided by p, a remainder is 1 always. P minus 2 factorial. When it is divided by p, remainder is 1. P minus 1 factorial. When it is divided by p, remainder is p minus 1 or minus 1. And where p stands for prime number. Now I am going to derive another formula. Under this another formula. This is quiz. You know 14 factorial when it is divided by 17, find the remainder. 14 factorial when it is divided by 17, find the remainder. 14 factorial means what? This is 16 into 15, because I know this answer is what? This answer I know. 14 factorial I derive here. This can be written as 16 into 15 into 14 factorial. When it is divided by 17, I am going to find the remainder. And I know answer for this one is what? For this one answer is what? 16 or minus 1. Now 16 by 17. 16 when it is divided by 17, remainder is what? Minus 1. 15 when it is divided by 17, this is minus 2. Minus 1 into minus 2, that is 2. If I take this 2 to right hand side, this is 16 by 2. Answer is what? 14 factorial when it is divided by 17. Answer is what? Answer is 16 by 2, that is equal to 8. And here answer is 8. Answer is 8. So can I write another formula here? P minus, the third one under Wilson's, P minus 3 factorial. When it is divided by P, a remainder is P minus 1 by 2. P minus 1 by 2. Under Wilson's 3 formulas are there. Just remember, or if something is given 13 factorial by 17, you can solve in this way. This is the proof. If you know this one 16 factorial when it is divided by 17, remainder is what? This is 16 or minus 1. This is the formula. P minus 1 factorial. When it is divided by P, remainder is P minus 1 or minus 1. If you know, you can derive everything. You can derive everything. Are you clear? Now under this we will solve a very good question. You just note this 3 formula 1, 2, 3. Then you solve this 3 example within second. Just observe the question, answer. But again important is this P must be a prime number. In Fermat little theorem, P also a prime number. If it is not prime, you cannot apply this. Okay? So it has the restriction. Fermat little theorem, Wilson's theorem have certain restriction. You cannot apply everything. Okay? Under this. Now under Wilson's I will solve another question. You just write, find the remainder. Just write down the question. Find the remainder when 34 factorial. Find the remainder when 34 factorial to the power 38 is divided by 37. Find the remainder. Find the remainder when 34 factorial to the power 38, when it is divided by 37, find the remainder. Find the remainder when 34 factorial to the power 38 is divided by 37. Is divided by 37. 34 factorial to the power 38, when it is divided by 37, find the remainder. Already explained कि p minus 3 factorial when it is divided by p, remainder is what? P minus 1 by 2. So here 34 factorial when it is divided by 37, the remainder is 37 minus 1 by 2. So 36 by 2, 18. So answer for this one is 18. Now here I will write 18, but power is 38. 18 to the power 38. When it is divided by 37, find the remainder. Now here, just think. You can directly apply Euler's theorem. 1, 2. Fermat little theorem. It will be easy. Why? Because this is a prime number. This is 38, but Fermat little theorem means what? Once again, under Fermat little theorem, the structure is when a to the power p minus 1, when it is divided by p, remainder is 1. So here this can be written as 18 to the power 36. If I write 36 here, I have to multiply 18 square, so that it will become 38. When it is divided by 37, find the remainder. For this one, if I apply Fermat little theorem, answer is 1, remainder is 1. Now 18 square is 324. 324 when it is divided by 37. 37 into 10, 370. 37 into 2, 74. So if I subtract 74, how much I will get? 370 minus 74. So 296. So 296 is divisible by 37. And here it is 324. So answer is 28. Answer is 28. Remainder is 28. So answer for this question 28. And here we apply Wilson's theorem. And here in this step I apply Fermat little theorem. So in this way you have to handle. And this is a good question. Important. Another key concept. When divisor is n to the power n plus or minus 1 form, how to handle? For example, quiz number 1. Suppose dividend is 2 1 2 1 2 1 up to 140 digit. When it is divided by 99, find the remainder. And here 99 means what? 10 square minus 1. 99, it can be written as 10 square minus 1. Okay. So when divisor is 10 to the power n, first note, when divisor is 10 to the power n minus 1 form, divide the given dividend into group of 2 digit each, into groups of, and here I write n, so into groups of n digit each, and add them to find the remainder. So when divisor is 10 to the power n minus 1 form, 99, 999, how to handle? Now whatever divisor is there, first you have to observe what is the power, n is how much. Here 99, so n is equal to 2. Suppose 999, then n is equal to 3. What this 2 signify? It indicate, now I do pairing, and in a single group how many digits are there? 2 digit. Here divide means I have to do grouping. Here it is written divide the given dividend. Divide the given dividend, here indicate what? Now I have to do the grouping. And in a single group how many digit present? N digit present. So rightmost, so last 2 digit here is how much? 2 1 2 1. So rightmost 2 digit, this is 2 1. Rightmost 2 digit, this is 2 1. Then 2 1. Then 2 1. Then 2 1. How many such pair possible? Total 70 such pair possible. That is 70 times you have to write. 70 pair possible. So if I add, how much I will get? Answer is 21 into 70. So this is 7, this is 14. So 1470. 70. 7 into 1, 7. 7 into 2, 14. So 1 0 is there. And now again this one is what? Greater than 99. So again you have to divide one to manually, otherwise same approach, rightmost two digits 70, then next two digit 14. If I add, my answer is what? 84. Answer for this question 84, or manual division also you can do. Key divided by 99, wastage of time. 99 into 199, this is 480. 99 into 4, this is how much? 396. So this is 4, and this is how much? 17. 17 minus 9 is 8. Okay, so 84. Don't do this. Don't do this. Apply this note. Apply this note. Then second bit. Understood na? If divisor is 99, so in a single group 2 digits are there. If divisor is 999, in a single group 3 digits are there. First of all, I do grouping. Then I have to solve. And always do the grouping from right to left. Rightmost 2 digit, 2 1, then 2 1, then 2 1, then 2 1. Up to how many digits available? 140 digits available. In a single pair, 2 digits are there. So total how many such pair possible? 70 such pair possible. So 70 times you have to add. So 21 into 70. Done? So here this is 10 to the power n minus 1 form. Now when divisor is 10 to the power n plus 1, just write it down. Okay. Six two five seven, and this one will continue up to 360 digit. When it is divided by 1001 or 101, okay, find the remainder. Because for 1001 I have to take 3 digit, one total 6, okay. But here rightmost 2 digit is what? 57, then 62, okay. So another note, this 101 is what? 10 to the power n plus 1 form. 10 square plus 1. This one is a 10 power is 2, 10 square plus 1. So first you write another note, note number 2, under this concept. When divisor is 10 to the power n plus 1 form, divide the given dividend into groups of n digit each, and starting from right, add them with alternate sign. Add them with alternate sign. So here rightmost 2 digit, this is 57, then 62. So here I will write rightmost 2 digit 57, then I will get 62, then 57, 62. In this way I have to continue. Now if this is my new pair, you know, you have to add them with alternate sign, and right, starting from right. So plus minus, plus minus. So what is the answer for this new pair? This is minus 5. Here also I will get minus 5. And in this new pair, how many digits are there? Total 4 digit. Total digit available 360. And this is 4 digit. 360 by 4, 90 times you have to write. And 90 times. 90 times I have to write this one. So answer for this question is what? This is equal to 90 into minus 5. And 90 times I will get minus 5. Minus 5, minus 5, minus 5. 90 times. Okay. So 90 into minus 5, this is equal to minus 450. But here answer is negative. So leave this negative first. Forget about negative. Now magnitude wise this is 450. But 450 is what? Greater than 101. So what you have to do? Again you have to divide. 450 divided by 101, remainder is 101 into 4, 404. So here 46, but negative sign is there, so minus 46. If one remainder is minus, other must be plus, and magnitude of sum of these two is equal to divisor. If one is minus 46, other one must be how much? 55. So answer for this question is 55. Every division has two remainder. One is negative, another one is positive. Final answer is always positive, but why we use negative remainder? To reduce the complexity of the calculation, we use negative remainder. So here minus 450 is my answer, but I know my final answer is always positive, but magnitude wise 450 is greater than 101. So again I have to divide. When I divide, I will get 46, and negative sign is there, so minus 46. If one remainder is minus 46, other must be positive. Other one is how much? Now 101 minus 46, that is 55. So magnitude wise it is 55. Clear here? Any doubt this structure? And if it is 1001, here this is a 3-digit pair number, again 3-digit number, plus minus, that means in a single pair 6 digits are there. So suppose whatever the digit available, let's say 600 digits are available, and here in a single digit, single pair 6 digits are there. So 600 by 6, 100 such a pair possible. When the question is 1001, when the question is 1001, similarly the value will be changed. Okay, they will arrange in that way. But when this is 1001, n is equal to 3, 3 indicate rightmost 3 digit. First you write plus sign, then minus sign, another 3 digit, and this is a new pair. That will become a new pair, and in a new pair 6 digits are there. So you have to check how many digits available, divided by 6, that much number of pairs are there. So this is all about remainder. Divisibility rule I will give you another session, and this is very easy, but under remainder, and this one is very important. Last year in each slot 1 questions are there, so it is very important, you just practice. Thank you.